So in the last video we were talking about, we've got this rock here, it says that it's 225 million years old. The only thing is we have discovered that there's two main ways to tell how old something is. First of all, we have carbon-14 dating, and what that is it's an isotope of carbon that half of it goes away every year. So it disintegrates. The half-life is that every so many years half of it's gone. So in carbon-14, we found that's a really neat deal. We can see how much carbon's in something because carbon is in anything that is living or has ever been living. But the problem is we have learned that carbon-14, when we get to a million years or 1.5 million years of carbon-14 dating, is no longer effective. It's so small that we can't measure it. So wow, so all of a sudden, some of the things that we thought we knew exactly how old they are, now in our new science, we're not sure. The other thing is we look at layers in the earth and we find something here and we know it's this old, and then we follow that layer and know that things are older than that down below. But once again, we found some problems with that theory. So we're not going to dwell on how old things are, but we are going to talk about what we do know. So, we know dinosaurs existed. Here's some actual fossils. Fossils are a great deal. This is a Tyrannosaurus rex claw. Okay, exact fossil. Okay, from the Tyrannosaurus rex. We can calculate how big it is. This is a Tyrannosaurus. This is a Tyrannosaurus rex tooth. Okay, so we know they're. We're going to come back and talk about these a little bit later. This is a shark's tooth. Can you imagine the shark that came off of? And it's petrified. It's turned to rock. So we're going to come back and talk about a lot of those things as we go. But we know these things existed. So when we look at science, we're going to be real careful now. When we talk about ages, we're going to talk about, be real careful. We're not going to be labeling a lot of packages here that say 225 million years old. We don't know. So anyway, that being said, that comes into play a little bit in our story of the whole, oh, shark tooth. Okay, so that shark was coming after me there, but I dove and got out of the way. Okay, now we're going to cover some things here and kind of go a little bit rapid fire here, so that you've got some things coming up for your next test. First of all, we need to know what makes up a living thing. Okay, so we look at something and we say, well, what's living? Okay, well, here's a shell. Okay, all right, this is a really cool shell. Is this shell living? Well, we look at it and you say, well, no, the shell itself isn't living, but maybe something was living inside this shell. Well, what makes a shell? What makes something living? Okay, so as we do these, and you're taking your notes, okay, these kind of things are going to be on the next test. First of all, cells have to, a living thing, okay, a living thing has to be made up of cells, okay, rather than atoms, all right? So a rock is made up of atoms. We'll talk about the chemistry of this, okay? A cell has cell organelles. It has parts, so it has to be made up of cells. And then the second thing is it has to be able to grow and develop. So characteristics of a living thing has to be made up of cells, has to be able to grow and develop, and it has to be able to adjust to the environment. Okay, so once again, characteristics of a living thing: it has to be able to, it has to be made up of cells. It has to be able to grow and develop. It has to adjust to changes in the environment. And number 4, it has to have the potential to reproduce. It might not reproduce, okay, but it has to have the potential to. So those are the 4 things that are characteristic of a living organism. Now, I want to tell you about spontaneous generation. This is part of our early history of science. Spontaneous generation is the idea that life can come from non-living things, okay? That life can come from non-living things. Well, that's what we used to think. We used to look around and we would be like for example, okay, if I had, this rock's actually called a geode, okay? This is actually out of the center of the earth, like through a volcano, okay? But it's got all these crystals. Now, imagine if you will, we're early scientists, early man, and we see this geode, and then all of a sudden, ants start coming out of the geode. So the geode is not a living thing. It's made up of atoms. It's made up of rock, okay? But imagine ants start coming out of there. So we look and we go, where did those ants come from? Oh, they came from this rock. So we assumed, okay, and once again, one of those early facts that got disproven, okay, that the ants came from the rock. So it's called spontaneous generation, the idea that life comes from non-living things. So when we saw the ants coming out of here, where did the ants come from? Oh, they were produced by the rock. Oh, well, that sounds good and it looks good. As a matter of fact, we would have these. They would have these old barrels, and they would throw rags in the barrels. And after a while, the mice would get in the rags, and so they would be like, "Oh, look, the mice came from the dirty rags. The dirty rags produced the mice." Well, we know now that that's wrong, okay? But they didn't know that at the time. Okay, so it's called spontaneous generation. Once again, life comes from dead things. So then there was a guy, a scientist named Francisco Redi. Okay, R-E-D-I, Francisco Redi, and he disproved spontaneous generation. And the way he did that was he got a jar. Okay, he got a jar, and he put meat inside of the jar. Well, when he put the meat inside of the jar, the flies came and they laid eggs inside of the meat. And then the flies hatched, and we had maggots and flies coming out of this meat. And so everybody said, the meat produced the flies. So he goes, okay, now watch this. So then he put mesh over the top of the jar. Okay, mesh is something that allowed the air to go in, but it was too small for the flies to get in. Okay, and as the flies came in, they couldn't get through the mesh, and the meat no longer had the maggots or the flies. He said it's because the meat didn't produce the flies. The flies came from living things. So Francisco Redi says he disproves spontaneous generation. He says life can only come from existing life. Well, that was kind of a big thing, okay? And we're going to talk about that because that's how we know a living thing is made up of cells. It grows and develops. It has the potential to reproduce, and it adjusts in the environment. Now, we already talked about a theory and a fact. A theory is an idea that hasn't been proven or disproven. A fact is an idea that has been proven given everything we know. Okay. So now we're going to talk a little bit more too about the language that we use in science. Okay. So we've got to be careful because we got to understand the American language. All right. Most languages are poetic. Okay. French, Latin, Spanish, okay, and we get a lot of Latin in our science. So in Spanish, okay, so French and Latin and Spanish are called poetic languages, where the language blends. Okay, like in Spanish we have uno, dos, tres, cuatro, cinco, seis, siete, and all the words blend together. Okay, but we got to realize that the English language, the American language that we talk, is not poetic. It's called functional. Okay, it's functional language. So we take off all of those poetic endings. All right, because we don't want to say, you know, for example, when we had in the metric unit of measurement, okay, a litre, L-E-T-R-E, is a unit of measurement of liquid measures. So it's called a litre. Well, in America, we just take that word and we just convert it over to whatever sounds the simplest, and everybody knows what we're talking about. So we don't say, I had a 2 litre of Coca-Cola, okay? Instead we say, I had a 2 liter. And so we just change it, okay? So you need to understand that when we hear these words, and we hear the science word, and then we just say it's been Americanized, okay? We just make it functional. See, in Latin, you have to go before a linguistic committee to be able to add a word. In America, you can add any word you want. Okay, that's a honking cool rock. Okay, as long as I can say whatever you understand and I can make it functional, it's okay in American. Okay, we can add any word. We can say that's a humdinger, or we can say whatever we want, and we can use whatever adjective. You can call it a whatchamacallit. We can do whatever we want as long as it's functional and you know what I'm saying. It's okay in American. So that's why when we see these words, we're like, okay. So an animal with a backbone is called a chordata. Okay, it's called a chordata. So what do we do in America? We take off the poetic ending. We just do away with that. I guess we just refuse to be a poetic people, okay? So we call it a chordate, okay? A unit of electrical current is called an ampere. So what do? We just call it an amp. So as you hear these different words and they sound different, just tell yourself, and if somebody wants to argue with this when you go to college and say, oh, it's not a liter, it's a litre, you just say, that's how we Americanize that word. So that helps us to understand when we hear something, especially if you're taking a test, you're taking a standardized test or an ACT or something like that. If you see a word and the word looks like an American word, but the poetic ending's off, it's the same word. Chordate, chordata. Okay? So we're going to talk about a few more things. We're going to talk about homogeneous versus heterogeneous. Okay? Homo means the same. Okay? Homo means the same. Geneous means consistency. So homogeneous. So if you're taking your notes there, Homogeneous. Homogeneous and heterogeneous. Heterogeneous. Homogeneous means the same throughout. Okay? So when we look at something, is it the same throughout? Milk is homogeneous. It's the same throughout. I pour a little bit of milk out, and it's the same no matter what. Heterogeneous means different. Salt and pepper. If I pour pepper out, pepper is heterogeneous. Okay? So then I want to move on. And I want to talk to you about there's two parts of an experiment. Okay? There's two parts of an experiment. The control and the variable. Okay? The variable is what we're testing. Okay, the variable is what we're testing. The control is all the parts of the experiment that stay the same. So if I've got two fish tanks here, okay, if I've got two fish tanks, and I want to say what kind of food works the best, and I kind of like Whoppers from Burger King. I throw a Whopper in this fish tank, and I want to see if it works good. Well, so I throw the Whopper in the fish tank, and all the fish die. So what's our assumption? Well, our assumption is that the Whopper killed the fish. Oh, did I not tell you that the water was 180 degrees? Oh, did I not tell you that I poured sulfuric acid in the water? Oh, did I not tell you? I could go on and on and on about all the different things. So we can only test one variable at a time. So if I want to see if the Whopper is a good food for the fish, I have to have two identical tanks. I have to have a control tank where the temperature is the same in both tanks, the plants are the same, the fish is the same, everything's identical except the one thing that I changed. So in this tank over here that has the Whopper, and this tank that has the fish food that I've been feeding them for years and they're looking the same, then if these fish do better, I know it's the Whopper. If they die, I know it's the Whopper. So two parts of an experiment, the control and the variable. Now we're going to cover some other stuff in the other videos. But I want to say one more thing at the end of this one, okay? I want to say that when we look at science, okay, when we look at science and we look at something, that we want to question things, but we want to make a hypothesis, like we said earlier. So as we go, you begin to become educated. So what we're doing is teaching you these things so that when you make a hypothesis about something, that it's an educated guess. And that's the difference between a theory and a hypothesis. A theory is just a guess, and a hypothesis is an educated guess. So, see you on the next video.